Welcome to The Explainer. So today we're going to talk about something really cool, the journey from just using Linux to really truly mastering it. We're talking from the kernel all the way up. This is your roadmap.
So let me ask you something, especially if you've ever typed ls or grep into a terminal. You know the commands, right? You know what they do, but do you really know how they work? What's actually happening deep inside the system the moment you hit enter?
I love this analogy because it just hits the nail on the head. It's the difference between being a good driver and being a master car mechanic. You know, the kind who can build an engine from scratch. See, almost anyone can learn to drive, but that master mechanic, they understand every single part, how it all fits together, and they can tell what's wrong just by listening to the engine. That's where we're headed. We're going to become the master mechanics of Linux. So, how do we make that leap? Well, it's all about a shift in your mindset. It's about moving past just knowing the how, the commands to type, and really digging into the why. What makes the whole system tick? And to get to that why, you need a good mental model. The best way to think about it is like an onion. Linux has these distinct layers, and to really get it, we just need to peel them back, one by one, starting from the outside and working our way in. Okay, so that first, outermost layer, that's what we call the user space. And honestly, this is the world you probably live in every day. It's where your apps run, it's where your bash shell is, it's home to all those commands you know and love, like ls and ps. If you go back to our car analogy, this is the dashboard, the steering wheel, the pedals, all the stuff you interact with directly. But here's the thing. For any of those programs to do something really important, like, say, read a file from the disk or open up a network connection, they actually can't do it on their own. Nope, they have to ask for permission. And that brings us to the next layer down, the kernel interface. Think of it like a super secure checkpoint. And there's only one way to get through it, by making a system call, or syscall for short. It is the only official way for a program to ask the core of the system to do some heavy lifting. And who do they ask? Well, that request goes straight to the deepest layer, the kernel itself. This is the engine. It is the absolute core of the operating system. It's the boss. It manages everything. It decides which program gets to use the CPU and for how long. It controls all the memory. It manages the file systems, and it's the only part of the system that talks directly to the hardware. Okay, so now that we have this mental model of the layers, how do we actually learn this stuff? How do you get that master mechanic's intuition? Well, it turns out you can build it on top of 4 key pillars. Yeah, this whole complex journey, it really boils down to getting good at these 4 distinct things. Let's break them down. And what's really cool is how these pillars build on each other. It's so logical. You start with the theory, the system internals, then you learn the actual language the kernel speaks, the system calls. Once you have that knowledge, you can start doing performance tuning like a scientist, not just guessing. And finally, you make it all repeatable and scalable with automation. See? It's a perfect path from knowing the theory to putting it into practice. Let's just double-click on that system call idea for a second because it is so important. Literally, every time a program does anything meaningful, saves a file, prints to the screen, sends a packet over the network, it is making a system call. It's the fundamental building block of everything that happens. Understanding syscalls isn't just some abstract theory. It's like learning to read the system's DNA. All right, so the big question is, how do you actually build expertise in these 4 pillars? It sounds like a lot, right? Well, we can actually break it down into a really practical 24-week plan that turns this huge goal into a series of clear, manageable steps. And look, this plan is structured this way for a very good reason. For the first month, weeks 1 through 4, you're just solidifying the foundations. That's the user space stuff we talked about. Make sure you're rock solid there. Then, for weeks 5 to 8, you take that first dive deeper into kernel basics. And we're not talking about memorizing trivia here. This is about building that mental model of the engine. Now, weeks 9 to 12, this is where the magic happens. You learn to speak the kernel's language. You'll use tools like Strace to actually watch the system calls happening in real time. It's only after you get that deep understanding that you can really start tackling performance tuning properly. And then, of course, you wrap it all up by learning to scale your skills with automation. See how each phase sets you up for the next one? It's perfect. When you get right down to it, this whole roadmap is about moving you from the column on the left to the column on the right. It's the difference between knowing what is inside the /proc directory and understanding why the /proc directory isn't even a real directory on your hard drive. It's a virtual window, a direct look into the kernel's brain while it's running. That's the leap we're talking about.
Okay, so we've got the technical skills, we've got the roadmap, but there's one last piece. Real mastery here requires a little shift in how you think, how you approach problems. It's all about adopting the right mindset. First things first, stop guessing. Seriously. Performance tuning is not some kind of dark art. It's a science. You measure a baseline. You make one change. You measure the impact. You let the numbers tell you what to do, always. Second, you gotta learn to listen. When something breaks, your first reflex shouldn't be to jump on Google. It should be to ask the kernel what's up. The DMS command, that's you listening to the kernel's own logbook. And you'd be amazed how often it just tells you, flat out, what went wrong and why. And number 3, and this might be the most powerful one, solidify what you know by teaching it. I mean it. The act of forcing yourself to explain a complicated idea, I don't care if it's a blog post, a tweet, or just explaining it to a coworker, that is the absolute fastest way to find out what you don't know and really lock in the stuff you do. Look, at the end of the day, this journey changes you from someone who just uses a system into someone who understands it, who can design it, who can architect it. The roadmap is right here. So I guess there's only one question left. Are you ready to start building?